A phone went on sale in China in September 2023 with no press conference and no announcement. It simply appeared on store shelves. The phone was called the Huawei Mate 60 Pro. Analysts bought one and took it apart. What they found inside stopped the semiconductor industry cold. A chip. 7 nanometers. To understand why that matters, a nanometer is 1/1000th of a meter. The size of a chip's circuits determines how fast and efficient it is. Smaller means better. 7 nanometers is at the cutting edge of what the world's best factories can produce. The chip was manufactured entirely inside China by SMIC, China's most advanced chip manufacturer. 3 years earlier, the United States had cut China off from every tool needed to build this chip. No advanced manufacturing equipment, no American software, no Taiwanese factories. The plan was to cap China's chip capability permanently. The Mate 60 Pro was China's answer. When analysts published their findings, US Commerce Secretary Gina Raimondo was in Beijing on a diplomatic visit, the highest-level American trip to China in years. She had not been briefed it was coming. Nobody on the American side had. This is the story of how China built the chip that wasn't supposed to exist. Zhengfei founded Huawei in 1987 with roughly $3,000 and a small office in Shenzhen. He was 43 years old. He had spent most of his career as an engineer in the Chinese military. He had no telecom industry experience. What he had was a belief that China needed to build its own technology rather than buy it from abroad. For 3 decades, Huawei grew. By 2019, it was operating in 170 countries. It had become the world's largest manufacturer of telecommunications equipment, the antennas, towers, and network hardware that countries use to run their phone and internet systems. Its phones ran on chips it designed in-house, called the Kirin series. Those chips were manufactured by TSMC, a Taiwanese company that physically builds chips for other firms. Think of TSMC as a factory for hire. You design the chip, they make it. At the time, TSMC was the best chip manufacturer on Earth. Huawei was also the world's leading supplier of 5G equipment. 5G is the latest generation of mobile network technology, roughly 10 to 100 times faster than 4G. Most of the world was about to build 5G networks. Most of those networks were going to run on Huawei hardware. Washington had a problem with that. But what Washington did not know was that Zhengfei had spent years quietly preparing backup plans for exactly this moment. In Chinese, Huawei employees called it living on the edge of survival. They were about to find out what that meant. In May 2019, the US government placed Huawei on something called the Entity List. The Entity List is a US government blacklist. Companies that want to sell technology to a listed firm must first obtain a government license. In practice, those licenses are almost never granted. The effect was immediate. Google cut off Huawei's access to Android, the operating system that runs on nearly every Huawei phone. New Huawei devices could no longer use Google Maps, Gmail, YouTube, or the Play Store. Qualcomm, an American company that supplies chips to most of the world's smartphone makers, stopped selling to Huawei. Intel cut off server components. Then, in August 2020, the rules expanded further. Any company that uses American equipment in its factories could not sell to Huawei without a license. That rule applied to companies in any country, not just the United States. It caught TSMC off guard. TSMC's factories run on American lithography machines and American software. Under the new rules, it had no choice. TSMC stopped manufacturing Huawei's chips entirely. Huawei had been stockpiling components for months. It had seen signs the tighter rules were coming, but it did not stockpile enough. By 2021, Huawei's revenue had fallen 28.6%. Its smartphone business, which had been the world's largest, collapsed almost overnight. Zhengfei addressed his engineers. His message was simple: survive, then rebuild everything. To understand what happened next, you need to understand how chips are actually made. A chip is a tiny map of billions of microscopic switches, called transistors, printed onto silicon. Those transistors switch on and off billions of times per second. That switching is computing. The smaller each transistor, the more you can fit on a chip. More transistors means more speed and efficiency. The number you hear, 7 nanometers, 5 nanometers, 3 nanometers, that is the size of those transistors. To print circuits that small, factories use a machine called a lithography machine. Think of it like a projector. It shines light through a precise pattern, burning tiny circuits into the silicon layer by layer. The most advanced version is called EUV, Extreme Ultraviolet Lithography. It uses a specific type of light with an extremely short wavelength. That shorter wavelength allows it to carve circuits far smaller than older machines can reach. Only one company in the world builds EUV machines, ASML, based in the Netherlands. Each machine costs approximately $150 million and takes years to assemble. The Netherlands, under US pressure, prohibited ASML from exporting EUV machines to China in 2023. Without EUV, the industry assumed chips below 10 nanometers were not achievable at any meaningful scale. In December 2020, SMIC was placed on the US Entity List. This cut it off from the newest manufacturing equipment entirely. On paper, SMIC was stuck at 28 nanometers. That was the technology level of 2011. The Mate 60 Pro contained a 7 nanometer chip from that same SMIC. SMIC did not have EUV machines. What it had were older machines called DUV, Deep Ultraviolet Lithography. DUV uses a different type of light with a longer wavelength. It cannot print 7 nanometer circuits in a single pass. The physics do not allow it. So, SMIC engineers used a technique called multi-patterning. Instead of printing each circuit layer once, they printed it multiple times. Each pass came from a slightly different angle. The overlapping exposures built up finer detail than any single pass could produce. Think of it like a basic printer. One pass gives you a blurry result. Run the same page through 4 times, shifting it slightly each pass, and the overlapping ink builds detail the printer was never designed to produce. It works. It is slower, more complex, and more expensive than EUV. More steps means more chances for a chip to fail mid-production. The percentage of chips that come out working, called the yield rate, is lower than what TSMC achieves. That makes each working chip more costly to produce. The Kirin 9000S inside the Mate 60 Pro performs at roughly the level of a 2019 Apple chip, about 4 years behind the frontier. It is not the best chip in the world. In fact, it falls far behind it. However, it is the chip China was told it could never build. A Canadian semiconductor analysis firm called TechInsights published the teardown report confirming what was inside. The US strategy rested on a clear assumption: no EUV, no advanced chips. China stays at 28 nanometers. Permanently, the Mate 60 Pro moved that ceiling to 7 nanometers. SMIC is now believed to be working toward 5 nanometers, using the same multi-patterning approach. Most semiconductor analysts agree 5 nanometers without EUV is extremely difficult, but it is not impossible. Below that, the picture changes. Reaching 3 nanometers without EUV is considered essentially unachievable with current techniques. The multi-patterning approach has physical limits no amount of engineering can fully overcome, so a ceiling still exists. It is just not where Washington thought it was. China is also trying to remove that ceiling entirely by building its own lithography industry from scratch. This is the harder problem. A SML's EUV machine contains approximately 100,000 individual components from around 5,000 supplier companies across 40 countries. It took more than 30 years to develop. The knowledge of the entire Western semiconductor industry went into it. Replicating that from scratch is a different kind of challenge entirely. China cannot simply reverse engineer its way to an EUV machine. The knowledge and the supply chain that built it took decades to assemble across dozens of countries. The gap between China and the frontier is real. It is also narrower than it was in 2020, and China is not stopping. The Mate 60 Pro was not the finish line, it was the opening move. By 2024, Huawei had rebuilt a full lineup of premium smartphones. It was back competing in the Chinese market. Its 5G network equipment business had survived by spending 4 years replacing US components with domestically developed alternatives. It costed billions, but it worked. Huawei is now selling 5G infrastructure across Africa, the Middle East, and Southeast Asia. The US has lobbied against it. It has not fully blocked it. In 2024, Huawei's annual revenue reached its highest level in company history. It had surpassed the peak it recorded before the sanctions hit. The company the United States had attempted to permanently cripple was now larger than it had ever been. Zhengfei had called it a prolonged war from the beginning. He was right about the length. The sanctions had cost Huawei years, revenue, and significant technological ground. However, they had not stopped it. That distinction matters more than it might seem. The chip that shouldn't exist is now inside millions of phones. The company that was supposed to collapse is posting record revenue. The ceiling that was meant to be permanent has moved. None of this means the sanctions failed entirely. Huawei's chips are still years behind TSMC. The gap is real. It costs real money to close. But the logic behind the sanctions has proven more complicated than Washington expected. Cut off the tools, contain the capability forever. That assumption did not hold. Zhengfei started Huawei with $3,000 in a Shenzhen apartment in 1987. 37 years later, his company is the world's most important test case. Can technology sanctions permanently stop a determined adversary? The answer, so far, not as cleanly as hoped. The chip keeps getting made, the ceiling keeps moving, and the company that was supposed to be finished is still running. If you enjoyed this video, then please subscribe to the channel. It supports us a ton. See you in the next video.